Welcome back, everyone. We're going to look at 7G today, which is all about Leslie matrices. And again, if we look at our syllabus in the external exam, we're going to be looking at dominance and Leslie matrices specifically. We looked at dominance matrices in the last video. Today, we're going to look at Leslie matrices. With dominance matrices, that was all about kind of rankings or creating orders. We looked at a sport team example. Leslie matrices is really thought of as like a population matrix. And essentially what happened was there was this guy called Patrick Leslie, and he was looking at population changes over time. And he kind of invented this particular matrix, which allows us to look at, is my population growing? Is it decreasing? In which particular category is it growing? In which particular category is it decreasing? It's actually quite a logical matrix to develop. So what he said, if I have some original population PO, or you can think of this as like P0, so like when time is 0. If I have some original population, let's just say I have a population of sheep. Let's just say I was a sheep farmer and I wanted to kind of investigate how my population was changing in case I needed to get a bigger paddock, or maybe I wanted to like bulk buy in some more food. I want to see if, do I have more sheep or do I have less sheep over time, so I can kind of create a plan for my farm. Well, one of the things I could use is a Leslie matrix. And whenever we do these Leslie matrices, we like to divide our population sizes into intervals based on the age. So I'm going to say this is sheep age between 0 to 2, between 2 to 4, and between 4 to 6. I've just done 3. Sheep live for about 10 to 12 years. So I could go on to do, 6 to 8, 8 to 10, 10 to 12. However, for this example, let's just do 3 and have a look at how this works. So I've got my 3 categories. Now I might say, okay, well, between 0 to 2, I've got 50 sheep between 0 to 2. Between 2 to 4, I've got 200 sheep. These are kind of the main ones I'm shearing. And between 4 to 6, maybe I have got about 150 sheep. So I've got about 200 sheep on my farm, 50 new sheep, 200 between 2 to 4, and about 150 between 4 to 6. So this is my sheep farm. This is my populations, like I said, divided into my age categories between 0 to 2, 2 to 4, 4 to 6. Okay, so now I want to look at the Leslie part of this matrix, which we typically refer to as L. And what Leslie found is once I've got my initial populations grouped into my intervals, I've got 3 rows this time. So I'm going to have a 3 by 3, and my Leslie matrices are always going to be a square matrix. So my rows will always match my columns. Because I've got 3 rows, my columns are going to be B1, B2, and B3. And what these 3 categories are looking at specifically is the birth rates based on each age category. So this is going to be and let's use different colors to reflect this. This is going to be the birth rate of my sheeps between 0 to 2, my birth rate of my sheeps between 2 to 4, and the birth rate of my little sheepies between 4 to 6. So I want to look at my 3 birth rates, and logically, this makes a ton of sense. How many babies am I getting, or how many new sheep am I adding into my population? So typically we look at birth rates, so how many new sheep am I getting? And we look at survival rates, which is how many of these newborn sheep are making it to 2 to 4, how many of my sheep age 2 to 4 are making it between 4 to 6. So these are kind of like the 2 key factors to my population preservation. So I've got my birth rates at the top. Then I want to include we call this S1. This is going to be survival rate 1. It's survival rate 1. And again, it's relating to this category here. This is the survival rate of my newborn sheep. So how many sheep age 0 to 2 are going to make it to the age of 2 to 4? Now, with this matrix, because I'm not concerned by the survival rate of between 2 to 4 just yet, or the survival rate between 4 to 6, I'm going to put zeros in those columns. I'm also going to put a 0 here because I've already calculated my survival rate between 0 to 2. And just to kind of highlight what I'm doing, if I multiply my Leslie matrix by my population matrix, I multiply my row by my column. So just to further articulate that idea, I'm going to have birth rate 1 times my original population, birth rate 2 times my second group, birth rate 3 times my third group is going to give me my new sheep. To do the second part, it's going to be survival rate 1 times my newborn sheep to calculate what percentage of those make it to 2 to 4. And then I want zeros here to get rid of this, zeros here to get rid of this. Then for the third section, I want a 0 here because I've already calculated my survival rate for my first population. So instead, I'm now going to have survival rate 2 in this section. I'm going to include another 0. This is going to be my survival rate 2 is going to be multiplied by my sheep aged 2 to 4. So I'm going to do survival rate 1 times my newborn sheep. and survival rate 2 times my sheep age 2 to 4. Now, I'm not concerned with the survival rate between 4 to 6, because in this particular model, I'm assuming essentially once they hit 6, that's kind of the end of the population. So if I look at what I have here, I have a Leslie matrix, I have a population matrix, and I want to multiply these two together to get my new population for my next time period. However, I've just got B's and S's. Let's just give these some numbers. I'm going to make these numbers up. I don't actually know the birth rate of these different sheep groups. I also don't know the survival rate, but if I was a farmer, I should have access to this information somehow. Or if I was working for the Bureau of Statistics, I would also have access to this information as well to create this type of Leslie matrix. So if I pick a number for birth rate 1, I did just Google this, and it turns out sheep reach the age of birth between 10 to 12 months. So we can have sheep giving birth in the 0 to 2 bracket, but because it's only gonna be about for 1 year they could give birth, I'm going to assume it's a really small number. I'm going to say my birth rate is 1.1, which essentially means for every 1 sheep, I get 1.1 sheeps as a result. Or about 10% of the sheeps are going to give birth. It's kind of one way, I guess, to think of this. So for my second birth rate, I'm going to assume it's pretty high. So let's do 2.4. So about 2.4 sheeps are being born per sheep. And my birth rate between 4 to 6, let's say this is going to be pretty low again. Let's say this is just going to be 1.3. So for every 1 sheep, I get 1.3 sheeps. To put in perspective, I think right now the birth rate for humans is about 1.8. So basically most women have just shy of 2 kids. So 1 to 2 kids is like the average family size here in Australia. So we can get these numbers for kind of any of our population groups. Now, if I go ahead and I include survival rates, well, let's just say between 0 to 2 to 2 to 4, let's say, let's do 0.6. So 60% of new sheep survive to 2 to 4. And let's assume once they reach 2 to 4, their survival rate's really good. It's going to be 80% of sheep that reach 2 to 4. Actually, let's make this lower. Okay, let's just say 40% make it to 2 to 4, but once they're at 2 to 4, they have a really good chance of going all the way on to, 4 to 6. So, okay, so there's my Leslie matrix. So in order to calculate my population after 1 time period, which we would call P1, because again, the idea here is to figure out, okay, if this is my Leslie matrix, what happens in 2 years' time to my population? I'm trying to extrapolate or look into the future to see what is my population trending towards? Increasing, decreasing? Is it going to explode? What's going to happen to my population? So if I look at 1, a good thing to note here is because I've done this as a 2-year interval, this 1 reflects after a 2-year time period. So basically it's saying, okay, it's been 2 years now, or I'm theoretically predicting in 2 years' time, which means all the sheep age 0 to 2 are now in the 2 to 4 bracket. All the sheep age 2 to 4 are now in the 4 to 6 bracket. And it's going to be my newborn sheep are going to be in the 0 to 2 bracket. So everything's kind of shuffling down. Am I saying, okay, are we growing or are we decreasing? So if I want to find population size 1 after 2 years, that is going to be equal to L multiplied by PO. Now, I'm going to actually do a few things here on the calculator to help make this a little bit more simple for myself. Okay, I'm going to use my calculator. I'm going to put my Leslie matrix in, and I'm going to store it because I'm going to need to use this thing a fairly large amount of times, and I'll show you what I mean. So again, create a matrix 3 by 3. We should all be able to do this skill by now. I'm going to put in my Leslie matrix. That's 1.1. That is going to be 2.4. This is going to be 1.3. I have 0.40000 0.80. I'm going to store this control variable as L. So I'm going to store this as L. Now, whenever I hit L, I've got my Leslie matrix. Okay. So my Leslie matrix is going to be stored as this. I'm also going to store my original population matrix as well. 3 rows by 1 column. That's going to be 50, 200, and 150. And again, control, store, let's call this P for population. So I've got my Leslie matrix, got my population. If I do L times P, L multiplied by P, there we go. I get this new matrix. So if I come back over here, and put those numbers in, that was 730. So it's going to be 730 20 and 160, which isn't looking particularly great for my sheep age 2 to 4. If that was the sheep that I was using to shear to get my wool, I've only got 20 left. I started with 200. I'm going to start being a little bit concerned. However, I've got heaps of newborn sheep, so maybe this is going to be okay, because now my sheep size has actually gotten bigger, just specifically in that 2 to 4 bubble. It's gotten really, really small. So again, for farming applications, it's really, really important to know, especially if this is like the money earning section, if this is where you get like your really high quality wool from, this is really concerning. But maybe if I just sell sheep or I trade sheep, maybe I sell newborn sheep, maybe this is okay. So just depends on the context a little bit for if we are concerned or not. However, I'm also trying to figure out what happens over a number of years. So I also want to find, if we get rid of this, I also want to find P2. So if I want to find P2, well, that's going to be my Leslie matrix times my population 1, because my Leslie matrix is going to be constantly being applied here, where it's going to be my birth rate times my survival rates, because those numbers are going to stay consistent for my sheep. So it'd be Leslie matrix times population 1. However, if I want to do this in a big setting, if I want to go straight to, let's say I want to go straight to P50, what happens after 100 years? What is my sheep farm going to look like? Because again, it's 2-year increments. So 50, 2-year period is a 100-year span, 100 years in the future. Well, if I want to figure this out, well, this by the same logic would be my Leslie matrix times P49. That's really annoying because you need to do this 49 times to get to this particular solution, and it's not very practical. However, the consistent element to this is I'm always multiplying by L. Well, if I do L times population 0, I get population 1. If I do L times P1, I get P2. So if I simply just rework this idea or this equation, I have population at 50, or actually, let's just make it K to reflect our rule. Population K is going to be equal to my Leslie matrix to the power of K times my population 0. Kind of created a rule here where essentially I'm just continuously multiplying by my Leslie matrix. If I times my Leslie matrix once, I get P1. If I times by a second time, I get P2. So if I want to find P2, I could simply just do, instead of P1, I could do the Leslie matrix times, or my Leslie matrix squared times my original. This is why it's really good to store these variables in my calculator. So let's go ahead and do that and see what happens after 50 years, just to get an idea of, hey, after a long period of time, is it increasing or is it decreasing? Okay, I'm back. So I'm going to do L to the power of 50 multiplied by P, my original population matrix. And if I look at that, my sheep population is absolutely gigantic. I have way too many sheep. That is 9 times 10 to the power of 14. So that's 9, but with 14 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's that number of sheep. That's more sheep than humans. So clearly our population is in really good hands. I've also learned that this would not be the birth rate and survival rates of sheep populations. Otherwise, we would have a massive problem. So maybe I need to change my business model. Maybe I'm not just looking at collecting sheep fur. Maybe I'm now doing a range of different things with the sheep that I have. So my sheep population is definitely massively increasing. Again, 100 years down the track is pretty far. There could be cold snaps, disease. There could be all kinds of things that could impact this population. So maybe what I really want is just to know, hey, what happens in 6 years? And if I do 6 years, whoa, I have a lot of baby sheep. I've got back to a very healthy population of sheep that I'm farming. I've got a few sheep at the end. So this is the general rule for my Leslie matrix. I can use this formula here to find my population. I can put really big numbers in to see trends. I can put small numbers in to see short-term gains. I can really figure out my population estimates at any point in time.